going to talk about the barcode hairpins. And this is primarily work that, oh, there we go, that Jeff Anderson Lee and Eli did. But Jeff was too busy to do a presentation, so I'm doing the presentation, and they can chime in with their thoughts on these things. But they did most of the work on this. So we were talking about the chemical mapping experiment and how it requires each sequence has a unique barcode so that researchers, after the experiment is complete, can identify the original sequence and then put those reads together. Previous Eterna projects have tested thousands of sequences at once, 3,000, 5,000. But now the technology, and that only required 7 pairs in the hairpin to provide enough unique barcodes. But now the technology for the DNA manufacturing has advanced such that much larger libraries can be synthesized and tested at once. So in OpenKnot round 2 and 3, the experiment tested 1 million sequences each. And so that required a longer barcode, and we went to a 13-pair barcode hairpin. The barcode pair strength had not been an issue recently because we've been using that shorter stem with only 7 pairs, is my feeling of why we haven't run into it. I did see some discussion about the barcode length or barcode composition. I go back in the forums early on, but it hasn't been an issue recently. And player intuition, we know how players know how to, that we know we need to mix AU and GC. We know we need to create balanced stems generally. So what I think happened in our OpenKnot round 1 and round 2 is our 2 of our wonderful players created these scripts for scanning long RNA sequences for pseudoknots and for mutating pseudoknots. And as part of the scripts, they generated a random barcode for fast submission. I don't believe those took the barcode composition into account, but Jeff and John can correct me if that's not true. So we ran into the problem with the ones that were created by the scripts. Players who were 1-by-1 designing generally used more balanced barcodes and did not run into this issue. So here's the barcode for anyone who isn't familiar. Here's our longer 13 barcode. And then this is the pairing, and it's paired to reduce degradation during the experiment to maintain the quality of this barcode so that it's readable. And therefore the sequence could be identified after the experiment is complete. This is a sequence I submitted in OpenKnot round 1. Again, it's the S2KL1, which is from the earlier Kissing Loop labs with Cody Geary. So I knew that this control would come through well because it's been tested with chemical mapping previously. And I used a mix of AU and GC so that the long stem would not be too strong and too stable to unfold during the experimental process. So the OpenKnot round 1 data, the researchers provided back to us a spreadsheet with the read counts and the signals, all that data, which allowed us to observe significant variation in the read counts. And Eli posted in the forum several times wondering why are we not getting any usable data for half of our sequences in round 1? And why is there such a huge variation in the read counts? And the data we got back, the usable data is for signal to noise above 1, was my understanding. So reads, as Hamish was talking about, is the number of copies synthesized and read for each design successfully during the experimental process. So what Jeff did was during for OpenKnot round 1, he submitted several series of sequences with the identical sequence but different barcodes because he wanted to test the influence of the barcodes on the results. And I believe it was particularly, he was curious about interference with the tail, but he can fill us in if I'm slightly off on that. I'm not 100% sure what his motivation was. In the data, after round 1, after we got our data pretty well processed and back in the game, I went to Jeff and said, what happened with that? We're talking about barcodes with the researchers and what we're going to be, I might make some changes in the future. And said, did you see any results from that? And so he went in and analyzed the results of his test, and he found a correlation between the OpenKnot score and the signal. I'm not going to be showing that data today. Jeff can share his spreadsheet if he wants to, people to look at that. But then Eli went a step further, and he noticed a even bigger correlation between the types of pairs in the barcode and the number of reads that came back for each design. So here's that result. So this is this barcode test. So this is Jeff's barcode test, and every sequence put in the area of interest is exactly the same sequence. And the only thing that he changed was the barcode hairpin. And so these are the best here at the bottom. The highest number of reads was almost 20,000. That had 4 GC. And then right there with it is 5 and 6 GC. And then there's a pretty big drop. There is this one here with 6 GC that had a little lower number, but that could have been due to some other issue going on with it. You can see there's quite a bit of a drop there once we start having 7 GC. And then this was the other submissions from his test with that same sequence that did not get back usable data. So it had low reads or had a really low signal. We don't know because we didn't get data for the ones that, we did not get data back for the ones that were not usable. And you can see how these all have 9 or more GC, except for this one here. Then Eli put together, he wanted to look at the sequences, the designs with the highest number of reads. And when we look at this list of the sequences with the highest number of reads, first of all, I believe these are all player designs, individual designs. I don't believe any of these came from one of the automated scripts, except maybe, yeah, I don't think any of them did. Yeah. And you can see that actually these all have a GU. So we'll talk about this in a minute. There's only one here with 7 GC pairs, but it had 2 GU. So therefore what Eli and I are thinking is that there needs to be a mix of pairs in order to ensure that that long stem is not too stable. So it's good to have a GU pair there. Can you stabilize it, or just there's one here that only has 1 GU pair and it has 5 GCs. This spreadsheet's available in the forum. I don't know, Eli, if you want to share it with people, the spreadsheet if they want to look at it in detail. And you can see these all have very strong signal to noise. But none of these are pseudoknots. It's kind of interesting. Oh, there is one here, actually. 2TPK, which is a PDB. That's a known pseudoknot. I don't think that matters. I don't think that has any influence, but it's kind of interesting to see. So what is happening here? Like Jonathan was asking in the chat earlier, why is this high AGC percentage causing a low read count? What problem is this causing them to experiment? So Eli and I speculate that the long helices, that long with such strong pairs, cannot unfold for reverse transcriptase. It could also be a problem during synthesis or during the last step of sequences. I'd be curious to hear other hypotheses. If players want to know more about the chemical mapping process, there was a town hall last July that Ray Huang from the DOS Lab did. And that's in the forum. You can find that posted there if anybody wants to see it. Why does it matter? Some of Jeff's test submissions produced data in round 1 despite having a strong barcode hairpin, but those designs had read counts between 1,000 and 2,000. In an experiment with 10 times or even 100 times more designs, those read counts will drop below 1,000, or Hammer says below 500 is the threshold. It would possibly be deemed unusable. Round 1 tested 120,000 designs, and round 2 tested 1 million. So, so I'm bringing this up. I want to show this to researchers to let them know this is an issue and what we found. And as players, we're not going to be designing for massive chemical mapping tests in the future, but it's still good to be aware of it and create a good barcode. In our smaller libraries, we're going to only be using the 7 base barcode, but it's still good for everyone to be aware of it. And hopefully this information will be useful for researchers performing massive chemical experiments who want to balance their read counts. Even if someone like Hamish is going to use that algorithm to do pooling, well, it'd be even better to first make sure they're making optimal sequences with optimal barcodes to eliminate as much error as they can on the front end before the pooling is done. Other implications for this, it's another good example of how a non-expert community can find trends and patterns that researchers do not have time to explore. Another thing is that the OpenKnot designs with low read count could be rerun with improved barcodes as part of a future chemical mapping library. They needed to be reused. probably would do better with a better barcode, or as also is happening, they're going to be pooled. But that was one implication for it. And it's also a good example of a meaningful test that players can construct for a lab puzzle. It's something that any player can do, is design, what do I want to test here, and put and submit those sequences. But be sure to only change one variable. I think was really key how Jeff used a known control sequence and then only changed the barcode. And then, so I would challenge players, are there other things that we could possibly be testing in our future OpenKnot labs, such as, can we identify any other reason that some of the designs have low signal to noise? So I want to thank Jeff for running the barcode test, Ray Huang, the DAS lab for producing the excellent data, Thomas for preparing the spreadsheets for us. They gave us the reads and the signal, and Riju for agreeing to share his data with us.